Hello everyone, and welcome back to this ggplot2 webinar. Can I give a quick feedback on whether you can hear me and see me okay? Otherwise I'll just be assuming. It seems to be working. Fantastic. Okay, welcome everyone, welcome back. I am happy that a lot of people decided to join me once again for this ggplot2 webinar. As I told you last time, this is the Corona edition of a webinar that I was giving at the celebration conference that was just like a month ago or something like that. So last time we had quite a lot of fun looking into the theory about around the grammar of graphics and also how it applied to actual the API of ggplot2, and we'll continue head fast into new territory today. If there are any new viewers, just quickly about me, my name is Thomas Liam Petersen. I'm a software engineer at RStudio, where I am responsible partly for ggplot2, but generally just everything graphics when it comes to R packages from RStudio. I was once a bioinformatician, but I have been moving away from that, obviously. I blog on Data Imaginist. I'm on Twitter on ThomasP85, and I'm also on GitHub under the same username. I don't think actually I talked about the picture on the right. That is made with ggplot2 by me. So never feel ggplot2 constraining you. Like you can draw almost whatever you want if you correctly figure out how to decompose the problem. So about today, or also about what happened last time, we talked about the grammar of graphics, and we talked about how that was reflected in the ggplot2 API. The reason why we had such a long webinar last time, I think it ended up being 2.5 hours, is that I think the theory is super important to actually understand why we do things the way we do in ggplot2. And the reason why it's important to understand why we do things the way we do in ggplot2 is that there's a theoretical backbone to it, and once you understand the logic of that theoretical backbone, you don't really need to understand everything and every function in ggplot2, because you can kind of understand the logic to it and you know where to look for more information. So having these two together, like the underlying theory of grammar of graphics, along with how that is reflected in the API, is super important, I think, which is why I decided to chuck them together into one quite long haul. So today we will be moving beyond ggplot2. ggplot2 is a huge beast. We didn't talk about every possible function last time. There are a lot to be done. But I hope that you can see how you can look into that yourself and pretty easily understand all these different aspects of it. And today we'll be moving into like the extended universe of ggplot2, which is the extension mechanisms that ggplot2 exposes, allows other packages to build upon the ggplot2 API, and I'll be talking mainly about that aspect. And the last part will be kind of a meta discussion part, where I kind of show a bit of how you can think with the grammar of graphics in mind, and how you can use that not to figure out how to make new graphics, but also how you can use it to actually inspect already made graphics and maybe even be better at understanding what's been shown to you. Same Arbeitsweise as last time. There are things that we will not talk about in this webinar. We will not talk about how to get data into R. We will not talk about data manipulation. We'll not talk about R programming. There are a lot of things that are important when it comes to doing data visualization that are related to data import, data manipulation, and in general programming. But that is for another webinar, possibly by someone else. But thankfully, there is a lot of free material online. These are some of the different packages that are central to a lot of people working with this, and they all have excellent web pages that you can browse into. And when it comes to R programming, Hadley has been making some fantastic books that are all available for free that you can dive into. So go nuts. Don't go nuts right now, because I want you to stay and listen to this. But afterwards, if you feel like you're lacking in some aspects in these areas, then definitely go check out these different resources. As last time, there is a GitHub repository for this workshop. I think I've been foresighted and actually put this link in the description of this video this time. I'm still learning as we go when it comes to streaming. But otherwise, you can visit this link where you can download an R Markdown file that you can open in RStudio or whatever you prefer to run your R code. And we can just have a quick look at it. You can see over here, there will be, for all the different plots that I'm going to show you, I'll actually also show you the code generated for the plots, and that code is also reflected in this exercises part. So you can go along executing the code, be sure that I'm not lying to you, that it actually works and it actually produces the plot that I'm showing to you. And then after each short section, there will be some exercises. And usually in a workshop, you'll have some time to sit down and dive into the exercises and try to solve them. That doesn't really work here, I think. So I will try to live code them, and if you want to solve them yourself, you can mute me, look away, and you can try to solve them at another time at your own convenience. You can also just follow along and then let some days pass and then try to solve them yourself. It's been so long since I made these exercises that I have absolutely forgotten everything about them. So you will see actual live coding where I try to figure out what I actually wanted to do at the time when I made these exercises. So there will be no cheating or anything. Yes. So let's get back to the slides. So the meat of today will focus on what I call beyond ggplot2, how you can move beyond what ggplot2 allows you to do, using a lot of the different extension packages already available. I didn't talk about this in the intro, but I don't expect this webinar part 2 to be as long as the last time. It's probably going to be between 1 and 1.5 hours or something like that, but we'll see. I honestly don't know, but there won't be as much material as last time. I have the same amount of water as last time, and I expect it to hold out. So big question when we're talking about extension is really why extensions? Like, why don't you just add more features into ggplot2? Like, that would be nice, and we wouldn't have to go looking for different extensions to solve our problems. The reason for that is mainly that ggplot2 is huge as it is, and just maintaining the current state of affair is a team effort. It is mainly being handled by me and Klaus Wilke and Dewey Dunnington and Yohaki, and I'm sorry, I can't pronounce his name. I'm sorry, Yohaki. And a few others. Kara Wu is also part of the core team, and Hadley is sometimes doing a bit of work, but not a lot. And as it is, it's quite huge already. Like my last count, we had 47 geoms, and we have 25 stats, and we have 62 scales. So there's a lot of functionality built into that already. And furthermore, we are actually constantly evolving the internals of ggplot2, and we'd rather focus on that, making sure that the internals are sound and safe, and let other people focus on new and fancy features. Hadley actually shared with me like I think the announcement for ggplot2 version 1 lately, where he talked about that this version number ggplot2 was famously a 0.9 version for the first, I don't know, 10 years of existence or something like that, and then suddenly it actually hit the 1.0 version mark, and when he released that, he told me, or he told the users that, well, this reflects that the ggplot2 is now actually in a stable format, and very little development will be put into it from now on. And he has been wrong before, and he was definitely wrong this time, because there is a lot of development going into ggplot2 core as it is, looking into how we can improve the existing functionality, and especially how we can allow extension developers to do more. So the ggplot2 is definitely not dead in any sense of the word, and it just keeps growing. So there's a lot of extensions out there, and many extensions are quite specific to a certain niche, and this is also one of the reasons why we feel it's better that experts within this niche will focus on developing things that are specific to them, instead of letting us, who may not know so much about these different types of visualizations, take decisions that may not be optimal for these types of visualizations. So it's way better to have a distributed development of new features, and make these new features be developed by people who really care about this area. Further, it's also quite a lot easier to promote new focus packages, instead of just having a continuous stream of updates about what's new in ggplot2, like having blog posts for this new fancy extension package is way better to actually describe new features. A lot of the feature, or a lot of the extension packages has been collected into a gallery, and this gallery is not maintained by the core team in any regard, but there were some problems with the domain of the last address for this site, so it has changed location a bit. So now we have allowed it to be hosted under the ggplot2.tidyverse.org domain. So you can now find it on x.ggplot2.tidyverse.org, and you'll find a lot of the different extension packages listed there. This is on an opt-in basis. So if you're developing extensions, you can create a pull request for this website and have your extension listed there, but it will not just pick up any new extension packages there. So it's not complete in any sense, but a lot of the big and very thorough extension packages are listed there, and it's a great way to just look in to see, well, what's actually possible at this moment. So the first thing I'm going to talk about is plot composition. And if you remember the last time, we talked a bit about facets and how people have tried to use facets for composing multiple very different plots together, and also alluded to the fact that this was not the best way to do it, because newer and better ways of doing this has appeared. But why even do plot composition? Well, mainly because when you want to tell stories with data visualization, it's very seldom that you can just create a single plot that will tell the full story. Sometimes it's okay to have like multiple separate plots intertwined with text and so on, but sometimes you also want to have like a complete story told by multiple smaller plots, all tied together in a single visualization. And this is really this is plot composition, and you want to be able to do that with whatever type of plotting framework that you want to do. This is not something. This is not a new demand. As I talked about, people have tried to do it with facet hacking, but there has also been a lot of different approaches throughout the years. Grid Extra has had a grid arrange function that some people are still using. ggplot2 has a ggarrange, cowplot has a plot grid function. All of these are just simply trying to combine multiple plots into an appealing composition in some way. Because I'm me and I am ruling what I'm talking about, I will overrule all of these and talk about patchwork, which is one of my own packages. And I truly believe it's the best way to do plot composition, but I will not force you to use it in any regard. Like if you're already using ggplot2 or cowplot or whatever, and feel like that is the best way for you to do it, certainly continue to use that. I will say though that if you haven't used any of these packages to do plot composition before and want to start doing that, I will definitely recommend Patchwork. It's the most recent one, and I'm also quite sure it's the most feature complete one. So, how does it look? Well, when we're doing plot composition, we need some multiple different plots to kind of show off. So here is one kind of boring plot showing the amount of sleep by different types of I guess it's mammals. I can't really remember. The sleep patterns of different mammals depending on whether they are meat eaters or insectivores or whatever. And we'll just create a couple of different plots to this. So not really anything interesting there. And you will probably see, as if you remember from last time, these plots that I'm showing are not meant to be stunning in like the insight that you are getting out of it. They are mainly used to kind of show what I'm talking about, so keep that in mind. So if we have these three different plots that I just showed you, and we want to combine them into a single plot using Patchwork, how would we go about doing that? Well, it's actually quite simple, because Patchwork's kind of claim to fame is that it extends the use of the plus operator, and as you will see in a minute, some additional operators to actually just allow you to add plots together. Now this is a horrible plot, right? I can absolutely see that this is not the best selling point for Patchwork because it looks horrible. The reason why it looks horrible is that there's simply not enough space for our panels in this area that we're looking at, because the three legends are taking up a fixed amount of space, and the different axis text is taking up a fixed amount of space, and there's only so much space in our plot. So it doesn't look good, but it's not the fault of the package. It's simply trying to fill out the area that has been given. We can improve on that a bit by, for instance, stacking two of them on top of the other one. And as you can see, there are different couple of different operators that allows us to actually do quite elaborate layouts of plots with a very, very little amount of code. So what we see here is that besides the plus operator, which actually is just adds plots together and place them in a grid, and that grid can have a number of columns and a number of rows. We can also use the pipe operator to stack or to position plots beside each other, so they will always be placed beside each other, and we can use the division operator to stack something on top of each other. And as you can see, you're able to actually nest plots down there using these things. So the two plots on top is a nested patchwork, which is then stacked on top of the other plot. What Patchwork is really good at doing is that it is absolutely enforcing that the plotting areas of the different plots stay aligned. No matter how complex your nesting structure and your composition ends up being, it will always align the plots. When I say align, it's simply aligning the plot area. So as you can see, the top left plot has it has a y-axis with some long labels, and we can see that doesn't inflict on how it's aligned with the bottom part of the plot, which has like only 20, 15, 10, and 5 as its axis text. So everything will always stay aligned no matter what you throw at it. Let's say There's a question here. I'll try to see if I can pick up questions as we go. There's one asking whether we can use patchwork for plots generated without ggplot2. And yes, you can. I don't think I have any examples of that right now, but you can use it with base package plots as well, and you can also simply add different grid objects together. So you can make a table using grid extra with a table graph and stick it together with your figure if you want to. So you can actually kind of catch everything that you want to plot and use it with patchwork. All that being said, ggplot2 is quite different from how base plot is working. So the alignment is not really possible to do when you're, for instance, if you're combining a ggplot2 plot with a base plot. It's not possible to have it automatically align everything. Patchwork is making a lot of assumptions. Assumptions are okay because I'm developing ggplot2, so I know the assumptions are okay about how the structure of a ggplot2 plot looks, and it uses that to ensure that they are always aligned. Okay. So what can we do otherwise? Well, if we have this plot composition that we saw before, there is a lot of space wasted in the main area because we have this legend in the middle of all of the things. And what patchwork is actually able to do is that it is able to say collect all the guides and place them to the side. Now once more you can see that, well, we don't have enough space to actually show all the legends right now. They get capped in the bottom and the top. Again, this is not really Patchwork's fault, it's just me being sloppy when I formatted the pictures. But as you can see, it allows a lot of quite nice dynamic things to happen. With this particular setup, we can actually see that we don't need any legends at all, because the two top plots are actually a kind of legend, because we see the colors are matched to the y-axis, so we don't really need any legend code at all. And we can turn that off, and what I'm showing you here is a new operator, which is the ampersand. And the ampersand allows you to add ggplot2 elements like theme or geom whatever to all of the subplots in your patchwork. So we can quite easily and with absolutely minimal code turn off the legend to all of our subplots in one single line. So that's quite nice as well, and suddenly we can see that we can actually show all of these three plots quite nicely in a single area. Now, usually when you do this, or maybe not usually, but a lot of time when you're doing this, it's because it's intended to go into some sort of article. So if you're in academia, you will usually have figures in your articles, and a lot of these figures are actually multiple smaller plots, and you will want to identify these smaller plots. So can you do that with patchwork? Of course you can. So we can do all sorts of plot annotations to the final patchwork. We can add a title to all of the things together, and we can also automatically tag the plots in there. So right now we say tag levels equals uppercase A, which means that it will use uppercase letters to tag them. We could have stuck in a lowercase a, and it will use lowercase. We could stuck in a 1, and it will use numerals, or an I to use Roman numerals, an uppercase I to use uppercase Roman numerals, and so on. So it's quite flexible in how you can actually tag this. Further, it actually allows you to dive into the nested structure of your patchwork. So for instance, in this example, we have the two upper plots are a nested patchwork inside a bigger patchwork. So we could add multiple tag levels and say, well, The top left plot would be A1, and the top right plot will be A2, and the bottom plot will be B instead. And Patchwork provides facility to do all of that automatically as well. So it does a lot of things that allows you to generate this this figure composition completely inside R, instead of having to go into other image editing software to add all the different things that you need to it. Which is nice, both because it simplifies a lot of things, but it also makes everything more reproducible, right? So let's see. Can we use plot layout globally, like ggplot theme set? No, you cannot right now. I think that you can. I have been contemplating on whether you should be able to set these things somewhere globally, either using options or using other facilities like with theme set. So that might appear in a later release. And someone is asking what is the reason for not using the plus operator for the theme? And as I talked about, the ampersand will apply the object to all of the different subplots. So if you only use the plus operator, it will apply it only to the last plot in the patchwork. But with the ampersand, it will actually go into each and every plot in your composition. And you can also manipulate the position of tag level letters. This is actually not a patchwork feature as such. ggplot2 supports the tag element natively, so you can add a tag using ggplot2, and this is simply what Patchwork is automating. So there are theme settings in ggplot2 that allows you to modify the different things. And can you align the title in the middle with Patchwork? You can do that as well. You can have a Patchwork level theme, and you can have themes settings for the different plots as well. Okay, let's move on. Before we go to animations, we should look into the different exercises that I have. Maybe I will actually answer some of your questions with the exercises as well. As I said, I can't really remember what the exercises are. Okay. So let's see what I have been thinking about. Patchwork will assign the same amount of space to each plot by default, but this can be controlled with the width and height argument in plot layout. This can take a numeric vector given their relative sizes. e.g. 2 1 will make the first plot twice as big as the second. So modify the code below so that the middle plot takes up half of the total space. So let's see, what do we have here? Oh, I was starting from a fresh session. And I also haven't loaded Patchwork. So the joy of live coding, right? Okay, let's see. We have a single plot, and we'll simply combine it with itself. That's quite boring, but just for illustrative purpose. So if I want to control the relative sizes of the different plots, I can do that with the plot layout function. As you can see, there's quite a lot of different arguments to this, and a lot of that can just be ignored. But let's see, if we say width equals c1.2.1, we can see that the middle plot will actually be twice as big as the outer plots. And the thing that gets bigger is simply the plot area. So it will never penalize a plot that has very, very wide y-axis, for instance. It will simply make sure that the plot area, the panel, is twice as big as the others, right? So I think one other thing that is possible to do is that widths can also be a unit vector. Let's see. So instead of just using numerics, we can actually set maybe potentially one of the plots to have a fixed size, like 5 centimeters or whatever. So if we see set unit see, the unit function is from grid, and you may stumble upon it when you're working with ggplot in general as well. So let's see, I'm going off script right now, so let's see, centimeters, maybe that's way too big, I don't know. And then null simply means fill out the remaining area. Okay, so so now the first plot will have a fixed width of 5 centimeters. No matter how we kind of resize the total plotting area, it will stay 5 centimeters, and the remaining plots will then just split the remaining area between them. Okay. Let's see, there are some questions coming up. I recently had problems when using patchwork to combine plots where one uses chord fixed when I try to give them different width. Yeah, so aligning fixed plots is tricky, and patchwork supports it to some extent, but it will try to do the right thing. But basically, if you have a grid of plots and maybe the middle one has a fixed size, and the total plot area has another aspect ratio or whatever, like you have to figure out where to concede, because you cannot solve this optimally in all cases. So sometimes it will shrink the plot to maintain the aspect ratio that it requires, which will then result in it not being aligned with the other plots. But it will try its utmost to avoid doing that. But in the end, if it cannot do that, it will simply shrink it. And maybe you've had problems because you ended up setting your plot in such a way that that it simply could not figure out a solution to it. Like it's basically a linear problem solution, and sometimes these don't have solutions. So yes, what's the next thing? The ampersand operator can be used with any type of ggplot2 object, not just themes. Usually it's used with themes because you want to modify the theme to everything at once. But it can be used with whatever type of ggplot2 object that you're usually adding with plus. So, oh, sorry, I don't know what happened there. So here we have 2 plots, and as we can see, these are aligned in the sense that the panel area takes up the same amount of space. What it hasn't been doing is aligning the actual values of the axis, and it's not doing that for very good reasons. Maybe there will be some automatic thing in the future, but basically it's not always that you want to align the axis. A lot of times the axes are not comparable in any way, so you don't want to align it. Right now, if you want to align it, you could do that by adding the same scale y continuous and setting the limits to something that kind of fulfills that fulfills what both of them needs. So so the lower one in the left plot is 10, and the upper one is let's just say 40 to be on the safe side. And as we can see, it has gone in and applied the same scale, y scale, to both of the plots. And since they take up the same amount of space, it means that all the tick marks are now actually aligned. Okay. Let's see. Patchwork contains many features for fine-tuning the layout and annotation. Very complex layout can be obtained by providing a design specification to the design argument in plot layout. And the design can be defined as a textual representation of the cells. So we use the layout below. How should the textual representation be understood? Okay, so we create 3 plots once more, and then we have this layout, which is just a text that is giving kind of a matrix of A, B, B, C. And instead of instead of doing nesting or whatever, instead of doing something fancy, we simply say, as a design for this plot, use the layout. And as we can see here, I hope you can understand what is happening. The first plot is placed inside the AA area. So this layout defines a 3x3 matrix, and the two left topmost cells will be used for the A, and the middle two rightmost cells we use for the second plot, and the single bottom left area will be used for the last plot. And everything that has this sentinel character, the comment character, in R at least, will simply be ignored. And these, like A, B, and C, is not something special. You can use numbers as well if you want to, like that, and we will get the same result. Hopefully, yes, we did. So it's simply like it arranges the different values alphabetic numerically, I think. So what if we mix it? Let's just see. So A will be the first one, yet, and then 2 and 3. Okay. Anyway, so you can see that it's possible to create quite complex compositions with this, right? So sometimes if you want something truly complex, instead of doing a lot of nesting and so on, it might be better to simply just define a layout, either using this layout specification, but you can also do it with, let's say, and now I have absolutely forgotten what it's called. You can make these area calls and simply just combine them with C. So area from the top one to the first left, and I'm thinking while I'm typing right now, so sorry about that. So for instance, this area here will mean that it will go from the top cells. It will occupy from 1 to 1 in the grid when it comes to rows, and it will occupy from 1 to 2 in the grid when it comes to columns. So this is the same as the AA up here, right? And you can just combine them together. I want to talk about this. Okay, that's it. So there's a lot of things that you can do with patchwork. I haven't even talked about all of the things, but just rest assured that you can spend a lot of time fine-tuning your compositions, and you can usually avoid having to spend time in an external program. Okay. So let's jump over to the next thing. So animations. Why animations? There's a lot of old and boring people who will probably say that animations are just a fad and it's just a shim and no one should use it because a nice static visualization is all you ever need. Well, maybe a nice static visualization is usually sufficient, and maybe it is usually the most correct way of showing data. But if you want to do storytelling, and especially if you want to grab attention of people, then animations are absolutely amazing. So, for instance, on Twitter or LinkedIn or whatever, if something is moving, like the eye is fine-tuned to detect movement, and you cannot look away. Like it is a fantastic way to grab the attention of people. And like the most perfect visualization is just meaningless if no one is looking at it. So there's nothing bad about wanting to grab people's attention. It is absolutely critical when it comes to wanting to tell your story that people are actually listening. So being able to make animations and being able to make data animations is quite crucial when you want to tell stories. as I talked about, it may turn off some people. Like some people will discard you as unserious when it comes to data visualization when you are employing animations. Don't listen to them, because it has value and it has a reason. There are many ways to make animations in R. There are the animate package where you simply just create multiple plots per one plot per frame in your animation, and it will stick it together. There's also a package called Movies, I think. ggAnimate is, I think, the only way to do that in a grammar way. So ggAnimate is not simply a wrapper around ggplot2. It is an extension of the grammar that ggplot2 is based upon, to kind of extend it to talk about animations. And as such, it works quite seamlessly with the ggplot2, and it can be kind of hard to see where ggplot2 stops and ggAnimate begins, because it simply provides new grammar elements to add to your plot, and it then takes over the rendering of the plot, so it's not static anymore, but it's actually moving. So if we have a static plot like this, boring economic data, one of the ways to make animation is to have a line appear as it goes through time. So this is a prime example of that. And the way that ggAnimate works is by providing especially a new type of object called transitions, which defines how the layer data should be interpreted in the sense of animations. So, for instance, here we add a transition reveal, and we say, well, it should be revealed along the date variable. And as we're using the date variable in our GM line for the X aesthetic, what we see is actually that we have an animation that simply shows the line appearing as date is increased. Now that is very little few lines of code that needs to be added to actually make an animation, and I think it's quite powerful in the sense that if you already have a ggplot2 object, making it move in some sense and in some ways is extremely easy to do, and it does not make you exit that grammar idea that you already have in your head. You kind of stay in a grammar world, and the only thing that you have to think about is that, well, we have extended our grammar now to also talk about animations. Now, transitions are not the only things that ggAnimate adds to the mix. If we look at this super interesting bar plot, where we just see the amount of cars that have different numbers of cylinders. Maybe you want to cycle through the years of the car models. In this data set, there are 2 years. Now what we can do is, and we're adding a bit more interesting things to the fact here, but what we can see is we're using a new transition. This time it's called transition states. It's kind of like a discrete scale in the sense that it defines some different states here based on year, and it simply just cycles through them. We can see the bars move depending on how many there were in the different years. As we have a situation where one of the year there are no 5-cylinder cars at all, we have to let a graphic element disappear somehow and enter somehow. And the way we specify this is by using enter and exit functions. So we can say when new data, new graphic objects comes into the visualization or the animation, we'll use enter grow, and when they go out, we'll just fade them away. And as you can see, that's exactly what's happening. One more thing is that ggAnimate also allows you to update the different titles, subtitles, captions, and so on in your plot using glue notation. If you're not aware of the glue package, it's a package that allows string literal interpolation in R. So the title that we set up here, number of cars in, and then these curly brackets, closest state, curly brackets in by number of cylinders. Everything that's contained within these curly brackets will be evaluated as R code and will be inserted in the string. Now, what is closest state? Well, the different transitions actually provide different variables throughout the animations that these labs or these titles will be evaluated against. So transition states will provide, for instance, closest state, which is the name of the state that is closest in time to the visualization. Transition states have both like fixed parts of the animation where it just stays in the state, and it has moving parts where it kind of moves between states. And closest state will always just return the state that is closest to it. There's also a next state, there's also a previous state, and so on. So you can modify your labels and update them quite nicely. So I hope it's obvious to you that just with these two examples, ggAnimate allows a lot of customization and a lot of very different types of animation, and it kind of takes this idea of a grammar and brings it into the animation world, in the sense that you don't need to support a fixed amount of different animation types. You just provide the different grammar objects, and they will just kind of work together seamlessly and allows you to define new types of animations. Okay, so let's just take some questions now. Okay, so there's one thing from Patchwork that I'll just briefly give you. What would be the approach to per-map the plus operator to a list of ggplots? So Patchwork provides a wrap plots function where you can just stick in a list of ggplots, and it will basically apply the plus operator to it like that. So that is usually what you want to do if you use Patchwork in a functional sense, where you don't know how many plots will be provided in the end. So how do you add text along plots? And okay, I don't really understand that. The animation is not showing up in my R Markdown, so maybe you need to install some packages for that to work. We can talk about that later. So can you save ggAnimate outputs in a file? And you can do that. So interestingly, ggAnimate, when it describes the animation, it keeps it unrendered, and it is only when you view the animation that it's actually rendered. And the way it's rendered is based on the renderer that you define. And there is a GIFSKI renderer that uses the GIFSKI package to combine pictures together into a GIF. There's also support for AV, which can make movies like MP4 movies or whatnot. And there's also support for making sprite-based animations and whatever. So that's up to your needs and wishes. So, can you combine different animations using Patchwork? This is something that is being asked quite a lot, and you cannot right now, but that will come. I happen to be the developer of both packages, and this is an obvious need that was intended from the beginning. It's just a matter of me having time to actually implement it. So let's look at some of the exercises. So the animation below will animate between points showing cars with different cylinders. So let's just library ggAnimate. Okay, so animations unfortunately are not instantaneous. A big part of what I'm doing at ggplot2 is to improve the rendering engine of graphics in R in general, and that will spill over to animations as well. But as you can see right now, it will render everything in one go, and then it will show it. I am unsure why it's not showing in inside the markdown file. I thought that was working. Maybe it's a new version of our markdown. Anyway, we have the visualization over here. So let's just maximize that. Okay, so this is not a good visualization, right? Or it's not a good animation. So let's just get down to them. So what we're looking at is that we have different cars, and we're showing the highway yield and the displacement of these different cars, and we will move between the different cars with different cylinders. And as we can see, the points are moving between the states, which is kind of implying that the same car suddenly have 4 cylinders, and now the moving things have 5 cylinders, and now they have 6 cylinders. And this is not true. Like, these are distinct cars, and you don't want to move the different points when it's not like being the same object that you're looking at, right? So how do we fix that? Well, ggAnimate uses the group aesthetic that's already present in ggplot2 to figure out whether an object is the same across states, and that's quite important to remember, because usually if you don't specify the group aesthetic and you don't have any different color or whatever, you don't really need to specify it, and the group aesthetic will just be set to -1 for all of the rows, which means that ggAnimate will think that that these point all belongs to the same kind of underlying data observation, and it will move them around. So we can get a better visualization by actually specifying the group, and we will just specify it to something like Siglan and row mpg. So we'll just give every point its own unique group, right? Let's just see how that looks. Hopefully something will pop up. Yes. And what we see now here is that there is no like movement of points between the different frames, which is actually what we want, because each point shows a distinct observation, not from the same cars and so on. And usually we can fine-tune this by adding enter and exit statements, so we have them fade in and fade out or whatnot. But basically this is what we want. And when I'm looking at animations in the wild, this is usually where people kind of forget to think about what the animation is actually conveying. If you don't have the same underlying object that you're representing, you shouldn't have that the graphical object move between states, right? Now sometimes you don't have to think about that, because sometimes ggplot2 will add the group for you. If you, for instance, have a discrete color mapping, then the group will be based on that color mapping. So if we say color factor cell, then the sorry, I lost my track there. Then the group aesthetic will be derived from this cylinder factor, and actually end up being as we wanted as well. So it is not always you have to specify the group aesthetic, which is kind of annoying, but you should always think about it, right? I will just let that think a bit. And I just answered the next exercise, so sorry about that. Let's see if it's ever done. This is not the best selling point for ggAnimate right now, right? Ah, there we go. I don't think my streaming software is doing anything positive to how long it takes. So anyway, you can see here it actually behaves as we want it to behave again now, because each point will not have the same ID across states anyway, so there will be no movement of the points. Okay, and this was what the second exercise was all about. So in the animation below, as in all other animations, the change happened at constant speed. Happens at constant speed. How values change during an animation is called easing and can be controlled using the ease function. Read the documentation for ease and experiment with different easings in the animation. So we'll just, while that is happening, we can't do that. Maybe we can. Look into help. So ease, it's a kind of a weird concept, and it will make more sense when you look at it. But as you can have seen when we saw the movement of the points, for instance, they are moving at constant speed, and that is usually not that that pleasing, right? Because they suddenly stop and they suddenly start, and this is kind of off-putting sometimes, at least. So what we can do is that we can say, well, the Y aesthetic should not move at constant speed. We will say it should move in a cubic in-out easing, which means that it will kind of slowly ramp up its speed and slowly go down in speed again. And all the different aesthetics can have their own easing if you want to, or you can just set a default easing for everyone to use. While it is animating, we can just have some questions. How does that ggAnimate deal with multiple layers? For example, movement path of animals on a map. Does it render the map for each frame? Yes, it does. It is treating each thing, each frame separately. But what it doesn't do is that it is not calculating each frame as a separate plot. So it is reusing as much as it can, but it will be rendering the map each time. But it will try to minimize the amount of work it has to do over and over again. How can someone regulate the speed of the animation with ggAnimate? So what we see here when we just type the plot out and it will print, it will just render something and it will take a fixed amount of time. And what is actually happening is that when you print it, in the same way as when you print a ggplot2 object, it will actually plot it. It will call the plot function. What happens with ggAnimate objects is that it will call the animate function. And the animate function has a lot of functionality. So when you're just printing the ggAnimate object, it will just use the default methods. And we can see here that there's a plot object, and then we have a number of frames per second and duration in seconds. So you have to specify 2 of these. If you specify 3 of these, one of them will be ignored. You can also, there's something called detail, which means that it will actually render more frames than needed and only show a number of them. And here we can also see that there's a render argument where you can pass in different renderers, for instance, the GIFKey render or the Magic render or the AV render or FFmpeg render and so on. And you can have a pause at the start, you can have a pause at the end, you can make it rewind when it's done and so on. I'm not getting any of the ggAnimate plots to work. Try Dave Ross's advice. I cannot troubleshoot during this, but if you have trouble making anything of this work, then please just open an issue in ggAnimate and we can figure that out. Okay. How do you make R show how far it is with the animation. So as we talked about, there is these, for instance, the closest state that we had in over here that we can put in, but ggAnimate also, irrespective of any transition you're using, provides something like the index of the frame or the progression between 0 and 1, which you can use to show how long you are. There are no kind of progress bar currently. This is something I'm looking into adding, so you can have kind of like a guide that just acts as a progress bar. Okay, let's just get back to ggAnimate and back to the exercise. Okay. As we can see now, instead of actually moving linearly, we can see that, that the plot will take up speed and then slow down again, which is often much nicer to look at, especially if the points are not moving along a time axis. If they're moving along a time axis, then you usually want them to move at constant speed because they need to represent that time truthfully. Okay. And we are done with animations. Okay, so this is just a very quick sneak peek into ggAnimate. It's quite of a beast of a package, and it has quite a lot of different transitions, and I'm planning on adding more transitions as for the next version as well. So you're not limited to the few that we already saw. Someone asked about bar chart races. You can do that as well, and you can do other stuff as well. So like the road is open for you to explore different types of animations based on ggplot2 setups. One thing that is particularly nice for presentations, for instance, is that you can have a transition filter where you have for each state in the transition you have a specific filter expression for your data, and we'll just show the data that actually that can actually fulfill that filtering statement. And you can also add layers gradually and whatnot. So there's a lot of possibilities there. Okay, so annotations. While we are at storytelling, this has been kind of the overarching themes with the extensions at this point in time. It's difficult to tell stories when you don't use words, and you can of course have titles and subtitles and captions and so on, where you can put in a lot of words. But annotations are simply simply much more powerful, like pointing something out on a figure with text and potentially other stuff. Is super impactful when you want to draw attention to something. And often when you wanted to do like beautiful annotation with ggplot2, you ended up exporting it as maybe an SVG file or whatnot, and then open it in, for instance, Adobe Illustrator. This is okay, of course, and if you enjoy doing that, or if you're kind of forced to do that because you want to do something that what I'm going to show you cannot really do, then that is fine. But we also end up in this non-reproducible state that we saw with plot composition as well. So the more we can move things into code, the better. And recent improvements means that we can move a lot of this into code. And I'm going to talk about two key packages for this, at least when it comes to textual annotation. This is ggRepel and a package called ggforce, which is not only about annotation. This is kind of a grab bag of different things, but it provides some very cool things to do with text annotations. So this is quite an ugly plot, but I think it's a quite common situation to find yourself into. We have some points, and we want to show what points are what. Like we have some text that identify these points, and we want to show what it is, right? This looks horrible because there's overplotting and there's way too much text on top of each other. It's simply illegible. Now ggRepel provides some new geom text and geom label geoms, which will try to kind of move labels around so they do not overlap. Now, what I'm showing you here is obviously not a beautiful plot. There's still way too much text here, but just to show that it is able to quite efficiently figure out where to put the different labels in a manner so it minimizes overlapping, and it will by itself draw these lines back to the origin point if the labels move away a certain amount of space. And now this is dynamic, mind you. So so if you resize the plot, the labels will be moved around. So it will optimally place the labels in the current situation. And usually when you try to do text animations or text annotation, sorry, you don't want to annotate everything anyway. Like you want to annotate maybe a few interesting points that you want to tell a story about. And ggRepel can also help with that in the sense that if you simply set the label of things that you don't want to label to an empty string, they will still kind of be there, and ggRepel will make sure that you do not overlap the points that they are linked to. So you can have maybe show a couple of points and make sure that the labels for these points do not overlap any of the points that doesn't have any labels. So that's quite nice. Now sometimes you're not as much interested in single points. You may be interested in groups of points, and ggforce, which is also one of my packages, has some really nice features for this. So there's a family of mark geoms. This one is called, the one we're looking at right now is called geom mark ellipse. There's also a geom mark circle, there's a geom mark rect, and there's a geom mark hull. And they all kind of do the same, but they're simply using different kind of enclosings to do the same. So geom mark ellipse will calculate the minimum enclosing ellipse for all the points that you want to show. And let's just walk through the code actually. So we have a ggplot, and we are using empty cars, and we are mapping displacement to the x-axis and miles per gallon to the y-axis, and we are having we're using geom point to show the actual points. Then now comes the geom mark ellipse call, and inside the aesthetic we have a filter aesthetic, which means that only mark the points that has gear equal 4. And then there's a label aesthetic that is that simply gives it a title, and we can also add like more text with a description. Cars with fewer gears tend to have higher yield and lower displacement, right? So what it will do is, as we talked about, it will calculate the minimum enclosing ellipse for these points and draw an ellipse around it, and it will actually expand the ellipse just a bit, so it makes sure that the line will not go over the points inside the ellipse. Further, it will create this nice text box, and it will create this nice, I think, aesthetically pleasing link to the original data. And this text box is actually placed in a manner so it will not overlap any of the other points. And as with ggRepel, it will move around as you kind of update the aspect ratio and the size of the plot. And you can have multiple ellipses within the same visualization, and the different text boxes will never overlap with each other as well. So you can be confident that the look will not require further tweaking with inside on the software, right? So this is quite nice. Let's see. Oh. And as we talked about, there are other types. So if you want to use a circular marking instead, we can do that. And if you want to have a convex or concave hull around the points, you can do that as well. Okay, so let's dive into the exercises. There we go. So ggRepel has a lot of settings for controlling how text labels move. And often the most effective thing is simply to not label everything. And there are two strategies for that. Either only use a subset of the data for the rebel layer, or setting the labels to the empty string for those that you don't want to plot, as we talked about. And try both in the plot below, where you only label 10 random points. Okay, so we have empty cast 2. And in empty cast 2, we simply take the row names of the empty cast and assign it to a label, so we can map it with ggplot, and then we'll simply say points to label, just take 10 random points, right? So this is not good, right? Let's just give it some more space to breathe. Okay, so this is kind of what we saw in the beginning. There's like a lot of points that have label, and it's kind of overwhelming. So what if we just say that for the geom text repel layer, we will just say, well, the data should just be empty cast 2 points to label, right? Okay, so now we only have a subset of the points that we're labeling, which is what we set out to achieve, right? But as we can see, there's the labels that we have, they don't overlap with each other, but they're still overlapping with the points that we do not label, which is simply because the layer doesn't know anything about the other points, so it cannot avoid overlapping them. So we want to avoid that and simply make sure that whatever label that we actually have in our plot will stay out of the points that we have in the plot. We can do something else. We can say, well, empty cast to label minus points to label. So points to label is simply an integer vector, right? And here we just say that, well, those labels that are not in this integer vector, we simply assign an empty string to that, right? So we do that, and now we do not modify the data. And as we can see, for instance, with the Hornet sportabout, it actually moved away from this point to the right. I just realized you cannot see my mouse, so I'm sorry if I've been pointing to Hornet sportabout with my mouse and thought you all knew what I was talking about, and obviously you don't. But anyway, in the last plot, the Hornet sportabout was overlapping with the point to the right of it, and using this approach, we can kind of circumvent this overlapping, which is super nice. So generally, this is the preferred way of doing things. Explore the documentation for geom text repel. Find a way to ensure that the labels in the plot below only repels in the vertical direction. And we could look into the documentation just to give you a sense of all the different arguments that are here. So this is quite a mouthful, right? A lot of it is for styling, styling the things, because you can style the line segment, and you can style the text, and you can style all different kinds of things. So in terms of figuring out placement, there is not that many settings. So what we can see here is that direction. We have an argument called direction, and we can say, well, move things around in both directions, or just move it in the X or Y directions. And what we were going for was, to find a way to ensure that the labels in the plot below only repels in the vertical direction. That means that we should set direction equals Y. Let's see how it moves. Okay, so now we can see that the different labels are all kind of centered around the x position of the point, and they will just move up or down like that. I think I'll just take some questions now. One of them is, can ggRepel be used to identify outliers? Outliers as such is kind of a weird concept in the sense that an outlier is kind of a human construct, in the sense that you decide what an outlier is. There's no way of telling whether a point is actually truly an outlier. It is only an outlier if you can explain why you label it an outlier. I know there are automatic ways of detecting outliers. All of these are wrong, in the sense that maybe it's not an outlier. Maybe it's actually the interesting point that you should look into. So ggRepel cannot be used to identify them as such. I'm not sure whether that's the question actually, or whether it's for labeling outliers. And sure, it can be used for that, but you're in control of figuring out what outliers are. So what can identify outliers, not just indicate an outlier exists? Again, these are all, there are statistical tests, but generally, if you want to figure out if something is an outlier, you need to go back and see how the data was collected, because that's the only kind of way you can explain that an outlier exists. We can see, well, this was collected in a false manner, then it's a true outlier. There are great packages for identifying missing data, which is not really outlier, but kind of in the same sense that you want to look into things that may not be there in your data, by Nick Tierney, called Narnia, which provides some extensions to ggplot2 for showing missing data. I know it's not directly what you asked for, but I was just it was just sprung to mind. Is it possible to combine ggRepel and ggAnimate so that the labels changes as the animation goes? Yes, it is. You can certainly use, like, ggAnimate will generally work with any well-behaved extension package, and ggRepel is a well-behaved extension package. So it works, but the way that ggRepel works is by kind of using a spring embedded layout, kind of forcing things away from each other, and as ggAnimate kind of moves along, you might have like some very drastic jumps in how the labels move around, because this spring embedding is calculated for each frame separately, and if there's huge changes to the underlying position of the data, then you will end up with some drastic changes in where the labels gets plotted. So it's kind of a hit or miss. Sometimes it works nicely, sometimes it doesn't. So that's just kind of how it is. Okay, let's get back to the exercises. So ggforce comes with 4 different types of mark geoms. Try them all out in the code below. Okay, so this is simply a plot. And as I talked about, there are different mark geoms. We can try this one instead, and we can see, well, we get a rectangle. And as we can see, the rectangle kind of goes out of the plotting area. And this is because the expansion of the rectangle happens after the rendering. So it's a fixed size, like I think it's 2 millimeters or something like that. So the extent of the plot has no way of reacting to this expansion. So we can just look into some of the different. We have this expand setting here. If we set that to null, for instance, we have no expansion. But as we can see, we actually have like things lying on the border, which doesn't look super nice. So this is the reason why there's default and expansion applied. Also, you can see that we have a rounding of the corners per default, and you can also just turn that off by setting the radius to 0, which will just reference the corner radius of the mark geom. So there's a lot of things we can do with it. Let's just see. We also have geom mark circle, which will, again, this will forcefully be a true circle, which means that a lot of it may end up being outside of the plot area if it's placed in the corner of it. That's just how it is. And if you end up with in that situation, your best bet is simply either not use a circle, or simply expand the limits of your axis to accommodate for it. One other thing that you could do, which we actually didn't talk about last time, is that one thing you can do in the coordinate system is that you can turn off clipping, which means that things that lies outside of the panel will not be clipped. So if we do that, we can see, well, it doesn't really improve the look, but you can actually see that it is still there. The last mark geom is called mark hull. And as we can see, it will draw, by default, it will draw a concave hull, which means it's not a convex hull as we used to think about, but this can be set. So if we set it to 10, for instance, it will be a convex hull. And we can make it more or less follow around the points by decreasing it. So setting it to 1, or maybe let's try to set it to 0.5 to see if we can make it dip even more. Let's just see what happens. Well, not a lot of change. Anyway, you can play with the concavity argument to simply figure out how closely it should follow the border of your data. One thing we haven't really seen here, like as I talked about, you can have multiple different marks in one layer, and it will make sure that the labels will not overlap. Let's just go back to this one. So we'll just ignore the labels for now and say, we'll say fill equals to gear. So now it actually, oh, this doesn't look super nice. Let's use the hull actually. Still not looking super nice, but this is simply because there's a lot of overlap between the different groups. So that's just how it is. But anyway, if you just assign a fill, then we'll behave kind of like whatever you would normally see, that you'll have multiple different groups, and here they will overlap. So in that sense, you can also set the label to be gear, for instance, and we will have the labels placed there as well. So you don't need labels. You actually also don't need the markings as well. So if we just say group equals that, and say fill equals NA. So now this is kind of nonsensical, but just to show, you can have one without the other if you want to. You can either have the labels, and you can have the grouping and closings, and you can have both of them at the same time, right? So there's a lot of possibility built into this. And sometimes you want to have create a big group of different things. Actually, I think, just a minute. So the first plot I showed in this section actually had, oh, there we have it. Sorry. There we have it. So this is obviously made with ggforce and the geomark ellipse. As we can see, we are marking a big area of points that has a general interest, and then we're actually marking kind of an outlier that sits within this area but is not part of that group, right? So you can do a lot of fancy things and a lot of storytelling using this, right? Okay, let's get back on track. Sorry for this short diversion. And there we are. Okay, we're kind of back on track now. Okay, before I go into network plots, I just want to briefly say that annotations is a lot of things, and here I'm only talking about text annotation. One other package that I will just briefly mention, and I think you should look into, is one called gghighlight, which allows you to kind of color specific points based on some conditions. So you have your general ggplot2 code, and then you simply say, well, right now with all this code, I want to make everything that does not fulfill this condition transparent or whatever, or I want to mute the colors of everything that does not follow this this condition, right? So this is another type of annotation where you kind of draw attention to certain parts of your area, and gghighlight, along with, for instance, ggforce, is fantastic to kind of draw attention to aspects of your visualization that you want the reader or viewer to take note of, because you can still see the underlying data, but it's very clear, and you're directing the eye of the viewer in a very clear way and saying, well, there's all this data, but look at this. This is the thing that you should really focus on. So at the moment, there's a fantastic amount of different annotation functions, and generally, as we talked about, a lot of storytelling functions built into ggplot2 and the extension system that allows you to not need to go into Adobe Illustrator or whatever, but can actually create publication-worthy figures directly in code without any type of post-processing. Let's see. Yes, I think we'll just move on. I'm sorry, I can't take all of the questions as it is. That's just how it's going to be. I can see that the time is already slipping, so so we'll hastily move on. So networks. This is another thing of mine. ggplot2 was generally built for tabular data, and ggplot2 was potentially one of the first packages to really enforce this idea of tidy data, even before tidy data existed as a name. But you have to keep in mind that this is really just an API decision. Like there's nothing in the underlying theory of the grammar of graphics that says that the data has to be tabular. So networks, for instance, is very, very badly represented by a single tabular data source. You can, however, represent it as two tabular data sources, one describing the edges of your network and one describing the nodes. So if you haven't really looked into networks in general, nodes are the things that are being connected, and edges are the things are the connections between them. Other names can be vertices, which is the same as nodes, and links, which is the same as edges, and there are a few others as well. So there are multiple packages that tries to do network visualization or add network capabilities into ggplot2. ggalley, ggNetwork, geomnet, ggtree, ggdag. So there's quite a lot. ggalley, ggNetwork, and geomnet has tried to kind of make a general approach to what I would call node edge diagrams. Some will call it hairball diagrams because they usually end up looking horrible, like a mess of things. This is not the fault of these packages. This is just like this visualization type is not suited for a large amount of data. ggtree and ggdag are more specialized. So ggtree is a package meant for creating especially evolutionary trees, but in general also all kinds of other trees. Tree, dendrograms, and so on are also network diagrams in the sense. And ggdag is specialized into creating directed acyclic graphs, which is a kind of also a kind of a tree, but it allows multiple parents. Now I'm not going to talk about any of these. I'll talk about gggraph, which is another of my packages. So gggraph is I'm sure most of the other authors of these packages will agree is I think the biggest package when it comes to creating networks, in the sense that it provides the most capabilities. And let's just dive into it. gggraph comes kind of hand in hand with another package called tidygraph, which is the package that allows for a tidy approach to network modifications, in the same, like it's kind of a dplyr plus per kind of package, but just meant for networks. So it allows using mutate and using filter and whatnot on network objects. So just to show off, we'll start by creating a network we call graph. And so this is a data set called Zachary, which is friendships between pupils in the Zachary Karate Club, which is a kind of like iris for network data. And we calculate a social clique for each of the nodes using the tidygraph function group infomap. So we're using a community detection algorithm called infomap, which simply assigns an integer to specify the membership of different groups, right? Now to plot this using gggraph, instead of using ggplot to start with, we'll use gggraph and pass it in this graph object. And now we'll just specify the edges and the nodes separately, because they are kind of separate data sources and they need to be treated separately. So we say gggraph plus geom edge link, which is simply just a straight line that connects nodes that has an edge between them, and geom node points, which is simply just kind of the point geom, and we'll color by clique, and there you have it. We have our network plot. Now it may look like with the gggraph call that gggraph is something that kind of sits by itself, but really what we're working with is simply a ggplot object, and the gggraph function sets up a ggplot2 object. It just does additional work under the hood that allows everything to work nicely. But it is, underneath it all, it's still a ggplot2 object. And we can see that by looking at it. Well, we can still use the standard ggplot geoms that we're used to. So here we're taking from ggforce geom mark hull, and use that to color the different cliques. So it's kind of powerful in the sense that it defines something that is specific to networks, but it's still just ggplot under the hood. And that means that it can also be used with patchwork, it can be used with gganimate, it can be used with all these other things that works together in the extended universe. So that's quite nice. Further, gggraph understands more or less all the different objects that are represented as networks inside R. So for instance, the output of hclust is an hclust object, which defines a dendrogram. And this can be understood as a graph object by gggraph. Well, underneath it all, it will convert them to the tidygraph representation, but tidygraph understands almost everything about networks in R. So you can be confident that most of the things that you usually work with, which are networks, can be used directly with gggraph. So here we're just saying, well, we create a hierarchical clustering of iris, and we plot this with gggraph using a new edge. We could use another geom edge elbow, which will draw kind of straight angles. But here we just kind of like this fancy organic look of a bit of a rounded corner. And again, we'll add geom node point, and we'll just add geom node. We'll just add points only to the leaves of this dendrogram. That means the terminal nodes of this tree. Now the leaf didn't exist in our input data, but different types of layout will kind of add additional information to your data source during computation. So this is all described inside the documentation. But when you're creating when you're drawing a dendrogram, you can be sure that there will be a leaf variable that says, well, is this node a leaf or not? And we can just use that and assign it to the filter aesthetic that exists for all the different gggraph geoms. Let's just take a quick look at the questions. How can I improve the rendering quality of my plots in RStudio? My guess is that you are on Windows. Martin, I can't pronounce your last name. And on Windows, the default device is horrible and it looks horrible. And RStudio is simply using the default PNG device to render its plots. So it will also look horrible. One way of getting away with that is to not use Windows, but that's not a really compelling argument to switch from Windows. But you can change, I think, you can change the default PNG device by setting a certain option inside with the options function. I can't really go into it, but you can look into how can I change whether I'm using Cairo or the standard Windows Windows rendering and so on. And if you set it to Cairo, then you will get much nicer plots. And that's just how it is. I can say that RStudio is looking into improving that because we don't like how it is. So you'll probably see changes to the graphic device in RStudio within the next couple of, I don't know, year, half year, a year, something like that maybe. So that's one way, but it's kind of annoying that if you're on Windows, the default just simply looks horrible. But that's just the sad state of affair. Why ggforce? I don't know if it's a question to the name, but that was just me thinking it looked sounded good. Okay. Is there a way for regular layers to access the edges too? Yes, there is. So when you look at the code up here, we don't specify that whether you're using edge data or node data in the different layers. It just simply follows that geom edge bend will access the edge data and geom node point will access the node data. Am I muted? Can no one hear me? Okay, people can still hear me. Maybe your computer audio is muted instead. I don't know. I take it that my mic is working fine. Okay. And so here we don't really need to specify anything in the different layers. But if we want to specify, have edges drawn by some other layer that does not automatically grab the edge data, you can do that by passing in the correct function to the data argument. I won't show it here, but I won't show it here, but you can get around that. Okay. Okay, people seem to be hearing me, so I think it's a fluke on maybe some network problems. Anyway, let's get into some of the exercises. So, oops. Okay, most network plots are defined by a layout algorithm which takes the network structure and calculates a position for each node. The layout algorithm is global and is set as part of the ggraph. The default is auto layout, which inspects the network object and tries to choose a sensible layout. Yeah, so, oops, I need to do that up here. Ah, my God. There we go. Sorry about that. Okay. So, as we can see in this this plot, the nodes kind of just gets placed somewhere, and they get placed in the sense that you get kind of an overview of your network structure, but you should be aware that this is just kind of a heuristic placement of the nodes. There are no true placement of the nodes, and there's a lot of different layout algorithms that use kind of different types of way of positioning the nodes, and none of them are actually kind of true. Which is one of the big problems in general with these types of network plots. You tend to look way too much into the location of the nodes, even though that these are kind of just a byproduct of the layout algorithm. If someone ever shows you kind of a plot like this, maybe even with bigger, even with bigger network data, and someone says, well, we can clearly see a cluster in this area, then be skeptical at the very beginning of that sentence, because you cannot infer clusters by simply looking at a network plot. Anyway, that was my my big setup there. So for instance, we can say that we want to have a layout that is based on, I just know by heart different types of layouts, and we can see the GEM layout algorithm is, okay, Kevin Stiers is acting up, so who is Kevin Stiers? I don't know how to ban people. I am sorry. Just a minute. I'm sorry for that. This stream in general is intended to be a very, very nice place for people to be, so please don't be idiots. I'm sorry I have to say that. But I have no idea. Board. I just removed his message. That doesn't work. Okay, sorry. I will just ignore the chat for a while. I am sorry if things are acting up in there and people are being idiots. I cannot patrol the chat while I'm talking. So, okay, let's get back on track. So as we can see, there are different types of layouts that we can try out, and it should just be said that none of these are true. Like you can try different out and see what's aesthetically pleasing for you or which kind of best tells the story, but they are all kind of just they're all just kind of byproducts of an underlying algorithm that is not objectively true. Okay. So anyway, sorry, I got a bit distracted on what was happening on the chat. I will just ignore it for now. There are many ways to draw edges as well. So let's just have a look at this plot over here. Here we have a high school data set, which shows friendship in a high school as it evolves over 2 different years. And this means that there are multiple edges going between the same 2 nodes. And we cannot see that here because all the edges kind of just overlap in the same way. But there are a lot of different ways as to draw edges. We saw geom-edge link before and here as well. And we saw geom-edge bend. And there are a lot of other things. So for instance, geom-edge parallel will take parallel edges and kind of just shift them a bit aside. Again, this is not a beautiful plot, but just as you can see how it works, it will take multiple edges and kind of spread them out The same thing can be done with geometry fan, for instance, which instead of drawing them as parallel, will kind of just give it different bends instead. So just to show you, there are a lot of different ways that you can draw your edges as well. And faceting works in gggraph as well as it does in ggplot2, but you should not use the built-in. You should not use your built-in facets from ggplot2 because they assume a single data source, and that doesn't really work. Instead, we can say that I want to facet the edges, and I want to facet them by, I think it's called the year column. And there we go. We have the subplot that corresponds to 1957, and another plot corresponding to friendships in 1958. So again, gggraph allows you to do a lot of the things that you will generally want to do in ggplot2. Okay. So let's get back to the presentation. Okay. The last thing I'm going to talk about when it comes to extensions is looks. Theming is one of the things that is one of the easiest things to extend. We talked about how we can do a lot of things with themes last time, and there is a lot of options with extension packages that provides a lot of different looks that you can just piggyback on. So if you don't have like this aesthetic or artistic gene where you want to look into all of these different settings that the theme provides, then you can simply look into some of all these nice theme packages and just pick a pleasing one. You don't have to be original to create nice plots, right? So these what you should think about is that a theme is often coupled with a color scale. So if you change the theme, the color scale that you use for color and fill will usually look out of place if you don't update it to change with it. And a lot of these packages comes with scales that fill and color scales that work quite nicely along with them. So a great starting point to simply make very pleasing plots is the HRBR themes. Which provides a very simple, very elegant theme, which is a fantastic starting ground for simply just changing it a bit if you want to, or simply just have a very elegant theme. It provides this theme ipsum, and it also provides a couple of others, and it provides color scales and fill scales to go along with it. There are also others more to the fun side, I would say. For instance, if you want to create, if you look back and wish for the times when the classic Excel existed, you can replicate it here, and then you will look at the default gray background with joy in your eyes, and that is kind of it. I don't want to go into the exercises for the themes because they're not that interesting and we are running short on time. So I'll just wrap up a bit. This ended up taking way longer than I expected, so thank you for hanging in there. The last part is kind of a talky part without any exercises. And I want to kind of go into the promise of the idea of drawing anything with ggplot2. So as we can see, there's a lot you can do with ggplot2, and there's a lot of things that that you cannot do just with ggplot2, but when you pull in the whole extension system, you can really draw a lot of things. But the grammar of graphic as it is, it's not just for creating graphs, it's also for deconstructing them as well. So when someone is presenting a graph to you, you can use this idea of the grammar of graphic to kind of break it down and better understand what is actually going on, and hopefully make sure that you're not that it is not cheating on you, and that you're actually understanding it in the right way. What you should keep in mind is that the grammar is actually ambiguous, and that is okay. That there's a lot of ways to deconstruct a graph and think about a graph. And one way we can look at that is to go back to our fantastic pie chart. So just let us think a bit about how does a pie chart fit into the grammar of graphic. We haven't really looked at it since the very first slide in part 1. So when we're presented with this, how should we kind of deconstruct it in a grammar of graphic sense? What are the geoms? What are the stats? What are the chords? What are the data? These kind of things is something that you can benefit a lot from by looking at the looking at the plot and thinking about where everything comes from. So if we want to create a pie chart with ggplot2, well, one way of doing it is that, well, we start by creating some data. This is just nonsensical data. But one way we could do it is by starting by creating this stacked bar chart where everything is in the same place and stacked on top of each other. And then we can apply a polar coordinate system to it, and then suddenly we have a pie chart, right? So this is something that fits very nicely within ggplot2, and this is one of the things that Leland Wilkinson actually ended up showing this first chapter where he talked about what is a pie chart. This is, well, a pie chart is a polar coordinate system, a stacked bar chart in a polar coordinate system, right? And we can just change a bit of the themes, and we have this look that we ended up having. Well, so a pie chart is a stacked bar chart in a polar coordinate system, right? Well, not necessarily, because you can also say that a pie chart is a wedge geom coupled with a stat for calculating radians. Now this sounds quite weird, but this is equally a true grammar representation of a pie chart. So if we're using, this is from ggforce again, as I said, this is just a package with a lot of different things, a grab bag of sorts. And for instance, it provides this geom arc bar, which allows you to draw wedges, and we just set the inner radius to be 0, so it's a full wedge. And then we use the pi stat, which will calculate the radians needed for a pie chart. And then we'll just draw it with chord fixed because we want a true circular representation. And we can just provide the same theme differences, and we end up in the same way. So what is true? Well, none of them are uniquely true, and it's just to kind of show that when you have a plot and you decompose it, you can end up going in different directions, and that is okay. Some of the choices that you make when you decompose it actually can influence what you can do with the plot that you end up creating. So for instance, if you have a pie chart in a polar coordinate system, you cannot really have exploded wedges if that is your fancy, or if it's the fancy of your boss, because you usually not want to make a pie chart with exploded wedges. And the reason for that is that it's very, very difficult to make linear transformations of the geoms when everything is based on this polar coordinate system. So if you really want to make exploded wedges in your pie chart, you need to do that in a Cartesian coordinate system, and then you need to think about a pie chart as a wedge geom with a pi stat applied to it. Another example of this is that when you look at a geom histogram, or a histogram, then in general you will think about it as a bar graph with a binning stat applied to it. This also simply has a geom histogram shortcut in ggplot2, and this is how we usually construct histograms in R, or with ggplot2 at least. Now, it can also be something else. For instance, you can use a binning scale instead and simply use geombar directly, because then the scale is actually binning the things. And as you can see, it dramatically, or not, maybe not dramatically, but it changes the look of what you end up with, because the binning scale has different axis ticks. So you'll actually have ticks between your bin bars, which for some applications can be super nice, and for other it's just overplotting, right? So this is just kind of teasers about what you can do when you sit down and think about, well, what this plot type, how is that represented by the grammar of graphics? And there are multiple routes to take, and there's a lot of different things to consider, and just the mental gymnastics of trying to translate things into grammar of graphic is really powerful, in the sense that it allows you to get more acquainted with the data that is actually being shown to you. So it's a very good thing to do. And one way that you can challenge yourself, and I hope I can challenge you to do that, is to look into this project called Tidy Tuesday. It has some a GitHub repository. It has a hashtag on Twitter, and it also has a Shiny app. So what is Tidy Tuesday? Well, the idea is that every Tuesday, the Tidy Tuesday group releases a data set, and then kind of invites everyone to explore it in their own way, usually with visualizations in some sort. And this results in a huge amount of different approaches to looking at the same sort of data, and I think it's a fantastic way to see what other people are doing with the same data set, and what other people are doing with ggplot2 or whatever else they're using. So just to show what some people are doing with ggplot2, this is Jake Kaup looking into a data set of different songs and what kind of characteristics these different songs have. So this is ggplot2 plot right out of ggplot2, and I think it's an amazingly beautiful visualization that kind of focuses on a couple of songs and how they relate to the huge amount of data that is there. Now, one thing that is super nice with the Tidy Tuesday is that a lot of people actually makes their scripts available. So you can look at the visualization, you can kind of try to guess what they're doing, and then you can get back and look into the script and figure out, well, what did they actually do? Was I correct, or would I have done it in a different way? Which kind of extensions did they use, and so on. Now, the same data set also resulted in this visualization by Cedric Scherer, where he instead looked into to hip hop and how it kind of evolved in the era of Spotify. And as you can see, this is not a single visualization. He has arranged a lot of different visualization. I think he was using cowplot, but I'll forgive him for that. And created this more storytelling approach to it all. Just to iterate, this is the same data set, more kind of an artistic taste, looking into 3 different playlists and see, well, how do they relate to each other, which areas are they focusing on when we kind of look into the songs that they're in the playlists. And just to show, first of all, what you can do with ggAnimate, but also generally that it doesn't have to be static visualization. So this is not the same data set. This is static right now. It shouldn't be static. Maybe I need to press a button. Otherwise, you must take my word for it. Oh, there we go. So this is a ggAnimate animation, where he's not looking at the same data set. He's looking at another data set regarding school diversity. Just to show, well, you can find anything in this Tidy Tuesday project, and you can really get inspired by a lot of talented people that kind of just sits down and think about some data and creates amazing plots. And for learning ggplot2, I think it's an amazing project. Even if you don't end up participating in it, simply just seeing what other people are doing. Okay, we'll be wrapping up now. So, just to say, if you want more about ggplot2 in general, and visualization in general, there's a book, ggplot2 Elegant Graphics for Data Analysis, which is written mainly by Hadley Wickham. And it is now a free book as well, so you can go into this ggplot2/book.org and have it all. And we're building up to a third edition now, which will be released at some point, but it will continue to be free as it is. One thing that we'll look into adding to this book is a lot more text about how actually to create extensions. So if I've piqued your interest in creating your own extensions, then there will be a lot of information there about how to get started with that. There are 2 other books that I want to recommend when it comes to data visualization. One is from Kieran Healy, which is Data Visualization: A Practical Introduction, which is also available for free. But generally, if you have the money, then support the authors, of course. Which is focusing on how to use ggplot2 specifically to create visualizations that you can use in your daily work. And the other is by Klaus Wilke, one of the core members of the ggplot2 development teams, which is called Fundamentals of Data Visualization. Now, this doesn't actually contain ggplot2 code. A lot of the visualization you should look into, or look in there, or see in there, sorry, is from ggplot2, but the book focuses more on theory and like what should you think about when you create and design visualization. So he decided to remove the code. I think he's been working on a repository where it's actually showing the code as well. So you can also have the code that goes with the book. Okay. A lot of the extension packages that I've talked about also has web pages where you can find both tutorial articles and references to the different functionality that's in there. So you can go in there and read more as well. And of course also explore the extension package website or gallery, where you can look into even a greater expanse of different extensions. So this is it. Thank you very much for attending. This ended up being way longer than I expected, so thank you for keeping up with me. I thought it would be 1 hour shorter. But this is the end of the workshop. I'll probably not be. I don't have anything planned for next week or whatever. This was kind of, I had this lying around and in memory, so I thought I would be using this coronavirus quarantine to just get it out there and educate. So I don't have anything planned now, and maybe I will look into adding more, maybe focusing on some of the extension packages that I talked about. But stay tuned. Maybe there will come more at some point. But until then, thank you and take care in these times. It's perilous out there. Have a good day.